Assalamualaikum. This week we are going to look into security engineering. As we know, security is an essential prerequisite for software quality factors such as integrity, availability, and safety. Why do we need security engineering? It is an activity to identify or to anticipate any threat, incoming threats for the software that you develop. The threat that might affect the assets of the software. These assets can be the information in the database, the files or the files in the database in the system, the programs, storage and processor capacity that have value to its stakeholders. There are three terms that involved in analyzing security requirements. So it is always the concern of the stakeholders, especially from the organization side, that the return of investment, because the organization has invested a lot of money to build or to buy the product, the software. So it is important to calculate the value, the exposure value. The exposure meaning the exposure of the software to the threat. So what is the effect in terms of time or cost to recreate a lost system asset? And then that's why threat analysis need to be done. Threat analysis is the process of determining the conditions or threats that may damage the system resources or the assets. And then after the threat is being identified, being analyzed, the team, meaning that the system developers team and the stakeholders as well, need to think of the controls, the security controls that are needed to avoid the attacks and to mitigate their damage. So we know that threats can be in any form, and this is an example of online security threats. We know that nowadays the internet, everything is open to public. So there are 4 types here in the slide, which is social media, networks that allow users to develop applications and have access to personal details of their users, mobile applications, native apps running on mobile devices may have the same access resources as the device owner, cloud computing, and the last one is Internet of Things. So in identifying threat, there are few steps, major steps that we need to do. The first one is security requirements elicitation, where we need to determine how users need to interact with the system resources. And then we create abuser stories that describe system threats, meaning that we create a scenario that what kind of threats that may happen. And then we have security modeling. This is where we develop a threat model, or we call it threat modeling. This one is done as early as possible in the SDLC lifecycle. So security modeling is to capture the policy objectives, external interface requirements, software security requirements, and then it helps the software engineers to think, to identify, or to anticipate the point of security attack. This is an example of security modeling or threat modeling. Okay, if you can see here, it is a simple data flow diagram for opening email attachment. So if you see here, the green items represent the trusted objects. Okay, and then the red items are untrusted one. meaning that we know, for example, in this figure, the attachment is the untrusted one. So we know that the attachment can be either a real attachment file, or maybe a file that contains virus, or attachment that is actually is a virus itself. Maybe the Trojan, okay, the malware that being sent by the attackers. And if you see here, the orange items are somewhat trusted. Circles represents logical processes within the component being modeled. Rectangles represent entities that you have limited or no control over, the rectangles. Double horizontal lines represent passive data stores and arrow represents data flow. So by having threat modeling, you can at least be prepared at which point of the data flow that the threat might happen. And then the third one, we prepare for the security matrix. So this is an example of security matrix. So it must be measurable, quantitatively measurable. So these are an example of security matrix. For example, total number of remote connections over 1 month period. So let's say if the number of remote connections is more than what you're supposed to have in a 1 month period, it will trigger alert. It will trigger alert. So this is where the control happen. Security control happen. The same thing, maximum number of concurrent remote by user. So let's say if you see there are more than the maximum number of user that being specified in the matrix, so it is something that the security team should be alerted. And last one, correctness checks to verify the activities and security test cases, meaning that we have to do after we identify the threats, we do the modeling, we design the matrix, we need to do security testing to see whether our model, our analysis are correct and trustable, and to give assurance to our security product. So all these things will be in artifacts, will become artifacts or evidences, or they call it case elements and auditable artifacts. Why? Because it is to support the contention that the software satisfies the claim being asserted, meaning that we need to assure the stakeholders that what the security analysis that the developer did before assure that the product is in a security state. So these are the three examples of security case elements: security claims, arguments linking claims to each other, evidence supporting arguments. Security risk analysis. Security risk analysis, there are a few steps. This is actually in modeling your threat model. These are the steps. Identify the assets. What are the assets relevant to the software that need to be secured? And this is need to be identified with the stakeholder. Then create architecture overview. Write the system use cases and build a model of the system components. Decompose the application. Identify threats. Note all the threats that might compromise the system. Document the threats. Create a risk information sheet. And lastly, rate the threats. And lastly, for this topic, by having security analysis, we assure the stakeholders the trustworthiness of the system. So the trust is a level of confidence that software components and stakeholders can rely on one another. Evidence is used to prove the security assurance. Okay, that's all for security engineering. The security engineering is about the process of identifying threats and to prepare for the security control. Thank you.